You are watching AliAziz Quality Education YouTube channel.
Piston Engine in BSc Aircraft Maintenance Engineering Technology, AMET, by AliAziz Quality Education.
AliAziz Quality Education channel, providing you the aviation industry related videos, so don't forget the subscription button.
A piston engine, also known as a reciprocating engine, is one of the oldest and most reliable types of power plants used in aviation. While modern airliners mostly use turbine engines, piston engines are still widely used in general aviation aircraft, helicopters, training aircraft, and light aircraft due to their simplicity, lower cost, and reliability. In the BSc Aircraft Maintenance Engineering Technology (AMET) program, the subject piston engine provides students with theoretical and practical knowledge of design, operation, maintenance, and troubleshooting of reciprocating engines. Objectives of subject piston engine: to study the principles of piston engine operation and thermodynamics, to understand the construction and components of piston engines, to explore different types of piston engines used in aviation, to learn maintenance, troubleshooting, and inspection procedures, to understand the regulatory and safety aspects related to piston engines. Main topics covered: 1. Basic principles of operation. Internal combustion process, Otto cycle and diesel cycle. 4-stroke cycle, intake, compression, power, exhaust. 2-stroke cycle operation. Differences between aviation piston engines and automobile engines. 2. Types of aircraft piston engines. Inline engines, compact, but less cooling efficiency. Opposed, flat, engines, widely used in general aviation, e.g., Cessna, Piper aircraft. Radial engines, powerful, used in older military and large aircraft. V-type engines, higher power-to-weight ratio. 3. Major components. Cylinder and piston assembly, combustion chamber, valves, spark plugs. Crankshaft and connecting rods, converting reciprocating to rotary motion. Camshaft and valve gear, valve timing and control. Lubrication system, oil pumps, filters, and cooling. Cooling system, air-cooled versus liquid-cooled engines. Fuel and induction system, carburetor, fuel injection. Ignition system, magnetos, spark plugs, dual ignition for reliability. Exhaust system, manifolds, mufflers, and noise control. 4. Engine performance. Power output and efficiency. Compression ratio and fuel requirements, aviation gasoline, avgas. Factors affecting performance, altitude, temperature, and mixture control. 5. Maintenance and troubleshooting. Routine inspections, daily, 50-hour, 100-hour checks. Engine overhauls and time between overhaul, TBO. Common defects, overheating, detonation, pre-ignition, oil leaks. Troubleshooting ignition problems, fuel starvation, and cylinder wear. 6. Safety and regulations. Fire hazards and safety precautions. Airworthiness directives, ADs, related to piston engines. Manufacturer manuals and maintenance procedures. Regulatory standards, EASA Part 66, FAA, CAA. Importance for AMET students. Builds fundamental knowledge of propulsion systems in aviation. Prepares students for practical training on light aircraft used in AME schools. Helps in understanding engine performance, reliability, and safety. Provides technical knowledge needed for EASA Part 66B 1.1 license modules. Career relevance. Knowledge of piston engines opens career opportunities such as Licensed Aircraft Maintenance Engineer, B1.1, aeroplanes with piston engines. General Aviation, GA, Maintenance Technician. Engine Overhaul Shop Technician. Flight School Aircraft Maintenance Engineer. Conclusion. The piston engine subject in AMET is essential for understanding the foundation of aircraft propulsion. Although jet engines dominate modern aviation, piston engines remain crucial for training aircraft, light aviation, and general aviation sectors. Mastery of this subject ensures students develop both technical and practical expertise in maintaining and troubleshooting piston engines safely and effectively.